Welcome to 10 minutes CS. 670 maximum swap. You are given an integer num. You can swap two digits at most once to get the maximum valued number, and we need to return the maximum valued number we get. So let's say we are given num 2736. Here we can see we can swap 7 and 2 and can get the number as this one. And for the other example, we see that it in itself is the maximum valued number, so no swap is needed and we just return the number itself. Here you see that the number is in decreasing order, hence no swap is needed here. So for any number to become the maximum valued number, it should start with the maximum number in the number itself. So let's say for this one, here we see we have 2, 7, 3 and 6. Among these all, 7 is the maximum, so we can swap it with 2 to get the maximum valued number, right? So what are we looking for? We see that this is the most significant digit and this is the least significant digit. So we should have the maximum number at the most significant digit. So from this side we should have the maximum numbers. Now how will we approach this question is, so let's say we are given the same example. So we can check for this index what is the maximum number we have on its right hand side. So it is 7, so we can swap here itself. So 7236, this will be our answer. Let's say we are given another example which is 9193. Here we check, here we see 9, and among all these values on its right hand side, 9 is in itself is the maximum number that we can get. So we go to another index. So now 1 is here, and on its right hand side we see that we have another number which is 9, that is greater than 1, and this is maximum among all the numbers on its right hand side. So we can swap these two to make it 9913. This will be the answer for it. So what is the first thing that we're looking for? We're looking for the maximum number on the right side of any index, right? So we can do this using the pre-computation. So for it we can create an array. Let's call it max right, as it will be storing the maximum number on the right hand side of the index. For populating it, we can store, let's say we have 9193 in itself and we are populating our max right array. So and its indices are 1, 2, 3. So this will have index 3 in itself because on its right side there is no element. For 9 we see that among its right hand side, that is I plus 1, that is smaller than the 9 itself. So this should store its index in itself. So what condition are we checking here? If the number at max right elements right side, this is 1, as this will be storing the index, and the number here is, if this is lesser than the number in itself, in that case we should store at max right ith the I itself. So we store the I itself. Else for the condition, let's say we have 1 and we see that this number is not lesser, so this is definitely greater than or equal to 1, so we store the index of it. So we can store maximum of I plus 1 in our max at I. So this will store 2 and 9 will be storing 2, right? Now once we have got all of them, we can check for each of these indices from the right. This computation we had done for our I from n minus 2 till 0. So this will be our second step. Now for our third step, we should do our computation from this side and check for each index whether we have a greater number on the right side of it. So we should run a loop, let's say from 0 till n, and for any case if we get a number, let's say we have num of I, if this is smaller than, that means we have got a number on the right hand side. How will we check where that number is and what that number is? We can check if the max has an element. So this will be the index of the right maximum number. If that is greater than our number itself, in that case we should swap both of these digits, and once we have swapped it once, at the time we can break it, because only one swap is allowed. Now we have done the swapping, we can combine the number and then return the number itself. Now let's look at the code for it. First of all, we see that the number is given as an integer. We are given an integer, not an array. So for this we are traversing over each of the digits. We can simplify it by making it a numeric array, or you can make a string array also. So here I have converted our number. We are given a number as digit. In the question it's given as num. I just change it to digit. We make it a string, and from string we create a nums array, and using that nums array we do the pre-computation and create our max right array, which is storing the maximum number on the right of the index. We do that same if else, the one that we just did above. We do it from n minus 2 till 0, while storing the n minus 1 as the n minus 1th index itself, and then we check if we have got any number on the right hand side greater than the number itself, then we do the swap, and once we have done the swap we can just break from here. Now we have to convert this nums array into a number, so we do another for loop and we convert it into a number, and we just return that number. Now what will be the time complexity for it? We are running over the, let's say we are given n number of digits in our number, so we run a loop of O of n here, then again O of n here, and again O of n here, and O of n here. So the overall time complexity will be 4 into big O of n, which is O of n in itself, and the space complexity will be, as we are creating another nums array here, so the space complexity will be big O of n. Thank you for watching.